Hello everyone, welcome to our presentation on chronic kidney disease prediction and hence ML approach. I am MD Fezan Ansari and my teammate Leela will be walking you through the live code shortly. Let's begin with the background. So our first topic is why chronic kidney disease matter. Chronic kidney disease or CKD is a global health problem affecting over 700 million people worldwide as of 2016. It's often called a silent killer because symptoms appear very late, usually in advanced stages. If left undetected, it can lead to kidney failure, requiring dialysis or transplant. Machine learning offers a way to predict CKD early using medical data non invasively and accurately. Our next topic is the foundation work. So, this project builds on a 2023 study by Chamandeep Kaur, where they used the UCI dataset of just 400 samples. They applied simple models, logistic regression, SVM, and decision trees, and achieved 97 accuracy using bagging. However, their approach had major limitations like small dataset, only three models, and minimal feature engineering. Our goal on all of these was to improve. The next topic is research gap and objectives, where to address those gaps, we define four key goals. Where the first one is to use a large data set with 20,000 real world patient records. Apply more models. We used 8 machine learning models, including XG boosting and gradient boostings. The third we did is perform advanced pre-processing and feature engineering, and the last one we did to conduct deep evaluation using multiple performance matrices. The next topic is dataset overview, where we used a dataset with 20,000 entries containing features like age, blood, pressure, albumin, creatine, and hemoglobin. We handled missing values with imputation, mean for numerical values, and models for categorical values. Label encoding and feature scaling were applied using label encoder and standard scaler, respectively. This ensured the data was clean and ready for model training. Our next topic is SEMA methodology, where we followed the SEMA framework, where the first one is sample, where we load and validate the dataset. The next is explore, where we use visual tools like correlation and heat maps. The next is modify, where we use engineer features and scale them. The next is model, where we train 8 machine learning algorithms. And the last one is asset, where we evaluate using matrices like precision, recall, F1, and ROC. This pipeline helps ensure a systematic approach to building reliable prediction models. The next one is model implemented. We tested these with 8 machine learning models, where the first one is logistic regression, which helps us to give the baseline. The next one is decision tree, which helps to find the simple and interpretable. The next one is random forest, which helps to say the assemble of decisions trees. And the next is SVM, where it helps for grid for boundary separation. And the next one is KNN, which helps for distance based. And the next one is gradient boosting, which helps for iterative and high performance. The next one is XGBoost, which helps to optimize and faster boosting. The next and the last one is Navy Base, which is simple and fast for classifying. Each model was evaluated fairly with same dataset and splitted. The next topic we have is data pre-processing. Data pre-processing included several stages like filling missing values using simple imputer. The next is encoding categorical data, and the next is normalizing numerical columns, and the next point is selecting best features using select KBS. And the last point is creating interaction terms like age, BP to capture deeper patterns. The next topic is evolution matrices, where to compare models we use the following terms, where the first one is accuracy, where we can find the overall correctness. The next one is precision, where accuracy of positive prediction can be seen. The next one is recall, where ability to catch actual CKD cases, and the next is F1 score, which helps to balance between two precision and recall. The next one is ROC, which helps the class separation capability, and the last one is confusion matrix, which breaks down of the prediction errors. The next topic is results, where our best performing models were random forest and XGBoost, which gives 100% accuracy with perfect precision and recall. The next is decision tree, which has given 98% accuracy with perfect recall. The next is SVM, which has given high precision and recall. And the last one is KNN, which has given moderate performance. High recall is especially important in medical context to avoid missing CKD patients. The next topic is key insights, where some key insights are assemble methods like random forest and XGBoost perform best. The next is interaction features improve prediction quality. The next is decision tree are useful for clinical interpretability. And the last point is the pipeline is robust enough for real world deployment. The next topic is conclusion and future work, where in conclusion, larger data are added with better features to give higher performance, and random forest is ideal for production, and future improvements like add genetic and lifestyle data, use shap or lime for explainability, and the third point is build real-time security dashboard, and the last point is integrate with hospital ehr systems. The last topic is acknowledgement, where special thanks to Chamandeep Kaur for their foundation work. Our data came from the UCI respiratory and expanded clinical dataset. Tools which we have used are Python, Pandas, NumPy, and Matplotlib. Thanks also for our mentors and reviewers. Now over to Leela for the hands-on demo. Thank you.
Thank you, Faizan. I'll now walk you through our live implementation in Python using a Jupyter notebook. Let's start by loading the data set. So here we can see that first we need to import pandas and numpy, then cbon. As for we will be using Python libraries for data handling, pandas and numpy will be used, and for visualization, Seaborn Matplotlib can be used, and for machine learning implementations like models, we will be using sklearn and XGBoost, and then loaded the dataset using pandas, and as cleaned the column names by converting to lower cases and replacing spaces with underscore. We have done that one. And in the sample step, we gather our data set and ensure it's ready for analysis by importing necessary libraries and loading the data. And then in the explore step, we are getting insights into the data distribution. Here we are converting the category values to numeric using label encoder, visualized relationships and distributions using SNS pair plots, and then SNS box plots. The SNS pair plots for multivariate relationships, and box plots are used for identifying outliers. We can see the pair plot, and we can see the box plot of the outliers. And during the explore phase, we examine our data closely using visual tools to identify patterns, outliers, and the overall structure of the dataset. Clean and the next goal is to modify and data pre-processing we are doing here. Then handle the missing values using simple implementer, simple imputer, applied feature scaling with standard scalar, created new polynomial features, selected best features using select k best with mutual info classic. In the modify step, we transform the raw data into a format suitable for modeling, filling missing values, scaling, and selecting important features. Here, this is a box plot. Here we can see the outliers. Then we come to the next step, model training. Train and test various machine learning models. As we are here splitting the data set as 80% training, 20% testing, and as we are using five-fold cross validation, this helps us train the models and evaluate them on unseen data. And in this modify step, we transform the raw data into a format suitable for modeling, filling missing values, scaling, and selecting important features. And then in the model training, we are using logistic regression model, support vector machine, naive Bayes, decision tree, random forest, k nearest neighbors, gradient boosting, XGBoost. We have used these models, and the model step is where we train different machine learning algorithms and tune them using cross validation to find the best performer. As here we have used this code to train and test the each model by using five-fold cross validation. It took a long time, little, and then this code would loop and execute and find the matrices like precision, recall, F1 score, support vector for every model we have generated. And here we can see the F1 score, the precision values. And as we can see, logistic regression got 87% accuracy. And we can see the confusion matrix. For support vector machine, we can get 94% of accuracy. And naive Bayes, we got 85% of accuracy. Gradient boosting, we got almost 99% accuracy. Gradient boosting, confusion matrix this is. And XGBoost, we got almost 99% accuracy. confusion matrix, and then comes decision tree. And here also, as we got 99% accuracy, and then random forest also gave us 99% accuracy. And then comes k nearest neighbor, and it got 92% accuracy. And by the model performance graph, we can see the graph here. We can see the comparison between the accuracies as which all the models gave the highest accuracy. We can see here. We have done the normalization and ROC curve, area under the curve, and then we are plotting the bar graph for each matrix accuracy, precision, recall, F1 score, and AUC area under the curve. For each model, we can see the bar graph here. So here finally we assess model performance using standard matrices like precision, recall, and AUC to determine which model performance best in predicting chronic kidney disease. As we come to the end, we can say to summarize this one, our best model was random forest with perfect accuracy and recall. And the pipeline we built is scalable, interpretable, and ready for deployment in medical settings. And then, as we have taken a research paper and implemented all this from parameter tuning to and optimization we did and included and extended this research to include many more advanced models. And then we have implemented models, almost models, and we have uh, normalization we did and pre-processing the data. Then we found the confusion matrix, and we used five-fold cross validation. Thank you for watching. Feel free to ask any questions. Thank you for your time. Thank you. You can go through our research paper. We will provide the link in the description. Here we are using SEMA model, which is the best method. So it can be used to get the best out of the model's accuracy. Here we have explained everything as data visualization, sampling, exploring data visualization, and then comes modifying, and we have modeled the models by training and testing. Then comes the last assess. We have assessed, and we got the conclusion. As we can see the conclusion, as random forests have gave the best accuracy, strongest performance, and we can see logistic regression and decision tree also offers a strong performance with added transparency. So as we have extended successfully the prior research and demonstrating that advanced preprocessing, feature selection, and ensembles methods significantly enhance chronic kidney disease prediction. The transition from 400 to 20,000 samples enabled model generalization and practical readiness. Yeah. Thank you. This paper will be available in the description. You can go through it. Thank you.